Hello friends, welcome to Catalyst Chemistry YouTube channel. As we discussed in the last video, most important point of what stereochemical aspect of what SN2 and SN1 mechanism also. Okay, in SN1 mechanism, you know very well about that. There is a two-step mechanism, that is order is what 1. SN1 is indicate what, you have to remember with the help of that point. 1 is what, order is 1. I will tell you how order is 1. Okay. Next, after that, in this case what two step mechanism is there. First, what there is a formation of carbocation. The second one is what the nucleophile is going to attack on that carbocation. That carbocation is a planar carbocation. The hybridization is what, sp2 hybridization. The bond angle is 120 degree. This is most important point. Okay, they are going to ask you what is hybridization of planar carbocation. You have to write sp2 hybridization. Okay. Next, after that, important point is what, that is stereochemical aspect of what, SN1 mechanism. Okay, stereochemical aspect. In stereochemical aspect means what, there is a formation of 2 points. One is what, D, another one is what, L. Small d and small l. D is indicate what, dextro rotatory, L is indicate what, levo rotatory. If the plane of the polarized light towards means start rotating in a right side, that is called what, dextro rotatory, indicated by what, positive. Next one is if the plane of the polarized light start rotating towards a what, left, that is indicate what, levo rotatory, that represented by what, small l. Or next one is what, positive negative charge. Levo rotatory negative charge, dextro rotatory is what, positive charge. Okay. Next, after that, where there is a 50 percentage of what, D isomers and 50 percentage of L isomers together, we are going to call racemic mixture. Bear in mind, this is most important point. They are going to ask you what is racemic mixture. I will tell you definition later. Okay, all those things point we will study later. Okay. That is why these 2 points are most important. Bear in mind, that is called what, D and positive, L, that is what, negative. Together we are going to call what, racemic mixture. Today in this class we are going to discuss the next important point, that is called what, difference between SN1 and SN2 mechanism. In examination they are going to ask you 2 marks. You have to write the difference between what, SN1 and SN2 mechanism. That time you have to write 2 difference for what, SN1 and 2 difference for what, SN2 mechanism. Okay. Already I wrote on the board. Okay, just see here, heading is what, difference between SN1 and SN2 mechanism. Okay, first this column is indicate what, SN1 mechanism, this column is indicate what, SN2 mechanism. Okay, just see here, in this case I have not wrote a order. Bear in mind, what is the order of SN1 mechanism means you have to write order is 1. How order is 1 means, that is most important point. Before that, you know very well about that what, that is mechanism. In SN1 mechanism there is 2-step mechanism is there. 2-step mechanism means what, the first step is what, that is called slow step. The second one is what, fast step. Order means what, that is depend on what, the reactant. In the first step only we are going to consider what, tertiary butyl bromide or tertiary butyl chloride. You have to consider any one of these 2. Okay. In that case what happen, the reactant means what, the rate of the reactant, the rate of the reaction is only depends on what, reactant. In the reactant side only one is there, no, tertiary butyl bromide, that can undergo what, planar carbocation formation. That is why the order is 1. In SN2 mechanism what happen, there is a 2 reactants are there. One reactant is what, CH3PAR plus what, KOH, that KOH is what, aqueous KOH. Okay, bear in mind, that is why alcoholic is different. This is what, aqueous KOH. I told many times, if the aqueous KOH is there, the OH minus act as a nucleophile. If the alcoholic KOH is there, the OH minus act as a base. What is the role of base? It can abstract the proton. What is the role of nucleophile? The nucleophile is electron rich. It can going to attack on what, electron deficient center. Okay, these 2 points are most important. In some time they are going to ask you what is the order for SN1. You have to write 1. This is the what, trick. Just with the help of this one you have to remember, SN1 order is what, 1. What is the SN2 order is what, 2. This is the what, trick to remember, but do not understand 1 is there, that is why the order is 1, not like that. Only the reactant, the rate of the reaction is depends on what, reactant, that is indicate what, order. In this case the reactant is only 1, but in this case the reactant is 2. One is CH3Br, another one is KOH, 2. But in this case you have to consider step 1. Okay, that is what the only one reactant, that is quaternary butyl bromide or a chloride. Okay, that is what most important. Just see here, order of reactivity of alkyl halide is there. In this case, what is the order of what alkyl halide? Order of reactivity. Primary is there, secondary is there, tertiary is there. Out of these two, which is more reactive in SN1? The tertiary is the most reactive. Why tertiary is the most reactive means what? There is a formation of what? That is planar carbocation is there, that is tertiary carbocation. Tertiary carbocation is the most important. Again question, why tertiary carbocation is the most important? Because hyperconjugation. You see first year concept, hyperconjugation effect. How many hyperconjugations are possible? Totally 9 hyperconjugations are possible in what? Tertiary, that is tertiary carbocation. That is why due to hyperconjugation effect, the tertiary is a more reactive compared to secondary, compared to primary. In some book means some people are going to pronounce this is 3 degree, that is also right. Okay, tertiary 3 degree, both are same. Okay, you can call 3 degree, 2 degree, 1 degree, no problem. Okay. Next, this is what? Order of reactivity. The next in this case, the order of reactivity of alkyl halide for SN2. In SN2, the primary will come first, after that secondary, after that what? Tertiary is there. Primary means you know CS3 Cl is there or CS3 Br is there, that is indicate what? Primary. Means usually generally we are going to call the carbon containing 2 hydrogen atom, that is called what? Primary. Okay, bear in mind. Okay, next after that secondary is there, after that what? Tertiary is there. This order is reactivity for SN2, this order reactivity for what? SN1. This is the first difference. Okay, next one is what? Follows the first order kinetics. Okay, clear? It is a what? First order kinetics follows the second order kinetics. Okay, I wrote, don't worry. In some book they are mentioned order is 1, that is also right. In some book they are mentioned the order is 2, that is also right, no problem. You have to write this one, otherwise you have to write normal, order is 1. Okay, this is what? Second one. Next one is what? Third one, concentration of the nucleophile can be low. In this case, concentration of the nucleophile can be low. In this case, concentration of the nucleophile should be high. Bear in mind, in SN1 the concentration of the nucleophile is low. Why in this case concentration of the nucleophile is low? Because of in this case the nucleophile can attack both the side. It can attack front side, also it can attack back side. Okay, it depends on what situation. That is why in this case the concentration of the nucleophile is low. But in SN2 mechanism the concentration of the nucleophile is high, because the in this case what happens, the nucleophile is going to attack in opposite side. That is what? Opposite side. Opposite side of what? Halogen indicate what? Back side attack takes place, not a front side attack takes place. That is why the most important point is, that is why in this case compulsory we have to maintain the nucleophile is high. Okay. Next difference, the nucleophile can be mild in nature, means both are almost same meaning. In this case nucleophile concentration is low, means in this case what? The nature is also mild or nature is also low. But in this case the nucleophile should be strong in nature, the nature is strong. That is why it can attack only what? Backside, opposite of what? Halogen. When opposite of halogen is there, obviously there is a formation of transition state, after that there is a formation of what? Finally. Okay, final state. The last difference in this case, the nucleophile can attack from both the side, I told right now only. Okay. Next, if the carbon atom, means if the carbon of alkyl halide asymmetric racemic mixture takes place, means now only I told what is racemic mixture. In SN1 there is a formation of what? Racemic mixture. The nucleophile can attack from both the side, most important. Okay, both the side racemic mixture is what? Possible. But in this case what happens, the nucleophile attack from the side opposite to what? Halogen atom, opposite to what? Halogen atom. Okay, that is why in this case there is a formation of what? Inversion configuration. Just here, if the carbon atom alkyl halide is asymmetric, if the carbon atom alkyl halide is asymmetric, 100% there is a formation of what? Inversion configuration. Okay, all these points are most important, bear in mind. Okay, make it perfect. Difference means they are going to ask you what? 2 marks. They are not going to ask you 3 marks, they are going to ask you only what? 2 marks. If you want, you can take a screenshot. Okay. Okay, listen here friends. Next concept is what? The basic stereochemical principles and what? Notation. In this case, what the definitions are there about what? Optical activity, optical isomerism, plane of what? Symmetry. Okay. All those things points we are going to cover in this case, dextro rotatory, levo rotatory, all those things, definition, what is racemic mixture. Okay. We will study this in this case. Okay. Just here, first point, the plane of polarized light is there. The plane of polarized light definition is there. Ordinary light consists of what? Waves. Ordinary light consists of what? Waves. Means you know very well about that. What light means? What this indicate what? Normal light only. This is having a what? Waves like this. You know very well about that PVC first year concept. Light is having a dual property. The one is wave, another one is what? That is particle in nature. Particle means try to understand the things as like a bullet. The bullet can move what? A straight line. The bullet will not move like this. That is why the ordinary light is having a waves in nature. Waves means what? Like this. This one is indicate what? This one is indicate what? Wave. Bullet means what? Light can move in this direction also, in this direction also. That is why the light is having a dual property. In this case, what happens? The ordinary light consists of waves which oscillate in all possible direction towards a what? Plane polarized to the what? Direction of propagation. Means very simple definition is there. Meaning of this definition is what? The light can light is, in this case we are going to consider light is act as a what? Waves. In this case, what happen? All possible planes perpendicular to the direction of propagation takes place. Means what? Oscillation takes place, rotation takes place. Okay, that is what most important point. Means if you want to more, means you know very well about that, the Nicol prism. Okay, Nicol prism means just I am going to consider like this. In this case, what the solution is there? Just I am going to pass the light. The light can rotate any possible direction perpendicular to the what? Plane of the polarized light. Okay, that is indicate what? The plane of the polarized light. Means bear in mind, very simple meaning of this one means in this case the light can possible all direction, means rotate in a all possible direction. Okay, clear. Next important point is what? Optical activity. Optical activity means what? In this case, compounds which can rotate what? Plane polarized light when it is passed through their solutions are said to be optical activity. The plane polarized light, optical activity, all are what? Connectivity points are. Just here, the compounds which can rotate the plane of polarized light when it is passed through their solution. Just here, in this case, this one is what? Indicate solution is there. Just when we are going to pass the light, plane polarized light, in this case what happens? There is a direction is possible. Direction is possible means what? It can rotate in a clockwise direction, that one is indicate what? Positive. It can rotate a anti-clockwise direction, that one is indicate what? Negative. This process is indicate what? Optical activity. This process is indicate what? Optical activity. Okay. That is why the most important point is what? In this case, they are going to consider a solution. What kind of solution they are going to consider? Sugar solution they are going to consider. All these things important in what? Nicol prism. This is takes place in a what? Nicol prism. That is why optical activity means it can rotate the plane polarized light when it is passed through their solution. Okay, that is indicate what? Optical activity. Okay, this is also bear in mind, make it perfect. They are going to ask you definition. Okay, next important point is what? A dextro and levo rotatory compounds, that is indicate what? D and L compounds. This is definition is very simple. If the compounds which can rotate the plane polarized light towards a what? Right direction. You know very well about that, the clock rotating like this, no, that is indicate what? Clockwise direction. If the clock rotating start like this means that is indicate what? Anti-clockwise direction. If the clockwise direction takes place, that is called what? D. That is what? D means what? Dextro. D means what? Dextro. If dextro is there, that is indicate what? Positive charge. Very simple. Next, if the plane of the polarized light rotate towards the left, that is indicate what? Levo rotatory, the represented by what? Small l, and next one is what? That is negative charge. Okay, this is indicate what? Dextro, and this one is indicate what? Levo rotatory. This is what? Plane of the polarized. Plane of the polarized light means you have to consider light is having a dual property. In this case, they are going to consider what? Waves. And means what? The light is passed through what? Solution, it start rotating in all possible ways, oscillation. Okay. Up to this what plain polar light, optical activity, dextro and Rotatory completed. The next important point is that is what optical isomerism, racemic mixture or symmetric molecule we will study later. Thank you.